Hello everyone, and thank you for joining me for my explanation of Lab 4, Resistors in Parallel Series and Mixed Circuits. Today we'll be looking at using Ohm's law, which is the current equals the change in voltage over the resistance, and transforming that so that we can get the resistance using the change in voltage over the current. Now looking at how these three resistors are able to act in series, we created a graph and got point collections on voltage settings. Now our voltage settings were 1, 5, 10, 15, and 20 for each of the three resistors, and then we tried to figure out what the total would be. So as you can see, as the voltage settings change, the current stays the same for all of these resistors. It does not matter the value of R, the current stays the same. On the other hand, the change in voltage is more related to the resistance of each resistor. As you can see, this one has 470 ohms and a value of 9.21 at the bottom here. This one is slightly smaller with 330 ohms, and so is the change in voltage. And like so, with the 220 ohm one, it's at 4.3, which is approximately half, which makes sense. Now, looking at the total, which is interesting, we were able to graph this. And now we have the change in voltage as the y-axis and the current as the x-axis, giving us that the slope of this will tell us what the equivalent resistance is. So for R1 in series, we got a value of 462 plus or minus 1 ohm. R2 is equal to 216 plus or minus 1 ohm. R3 is equal to 324 ohms plus or minus 1. And the R total is equal to 1,004 plus or minus 4 ohms. Now this indicates to us that when resistors are in series, they are added together to get a total resistance. And here is our equation for that. R1 plus R2 plus R3 equals R total. Now moving on to our resistors in parallel, we did a similar thing where we measured all three of the resistors at various voltage settings of 1, 5, 10, 15, and 20 when they were arranged in parallel. And as we see now, the current does in fact change, while the change in voltage actually remains pretty much equal for all of these. So it's like the inverse of what happened when they were in series. Now again, we put this on a graph with our x values being the current and the y values being the change in the voltage, and we got this. Using a linear regression, we then looked at what these were equivalent to, and we got similar answers from before. R1 being 466 plus or minus 5 ohms, so a bit more of a range there. 327 plus or minus 3 ohms for R2, and R3 being 219 plus or minus 1 ohm, and then in total being 131 plus or minus 1 ohm. Now this is interesting because it definitely indicates that when the resistors are in parallel, they act a little bit different. And in fact, what they are actually doing is this. When they are in parallel, this is how they are added together, which is 1 over R1 plus 1 over R2 plus 1 over R3 equals 1 over total. And like I said before, as the voltage changes, the change in voltage remains the same, and the current grows at a constant rate based on the input. So thank you very much. I hope this was helpful for you and you learned a little bit about what resistors do in parallel versus resistance, and have a nice day.